This is my first talk actually talking about this stuff. I did a small sneak peek of what I'm going to be talking to you here at DEF CON last year, and I plan to do it at a lot more larger stage this year as well in different ways with different tools. So first of all, let me give you a quick introduction of myself. My name is Abhay. I work for a company called V45. We're an application security company. I started off in PCI compliance. I also wrote a book about it. Then I kind of moved towards application security entirely. I fell in love with application security, did a lot of pen testing. Then I realized that obviously pen testing needed to evolve a little bit more. So I got heavily into DevSecOps, which is essentially how do we achieve better application security outcomes in a continuous delivery pipeline? How do we ensure that as companies or as organizations are going at rapid scale or deploying very quickly, how do we ensure that security is part of each and every deployment or each and every release that they do? So that's been my chief aim for the last 2.5 years. I also developed a product called Orchestron, which is a correlation and orchestration tool. I speak at a bunch of conferences, do a bunch of training. So that's a quick introduction of me. I got a lot of demos today, as you can see. And one of the things with demos is that they seldom work. So I'm just praying to the demo gods to make sure that all my demos work perfectly fine today. I have 2 or 3 demos, and some of these demos were a little bit weird till this morning. So I'm just hoping that they go okay right now. So just before I start, so don't blame me if something goes wrong. I've tried my best. Right. So today I'm going to be talking a little bit about DevSecOps. In the sense that I don't think I need to sell you on DevSecOps anymore, right? Pretty much everybody in this conference is aware of DevOps, is aware of DevSecOps to a certain extent. Even if you're doing it or not doing it, you're aware that there's something called DevSecOps, and you're aware that it has a lot of value for your own organization, for your own product, whatever, right? So I'm not going to sell you on DevSecOps, but I'm going to talk about a few key issues that we keep facing with DevSecOps as well. So just as we had issues previously where application security was not moving with the pipeline, application security was not keeping up, now we're having a different set of issues. So in many cases, I've seen these issues and they've become pretty pernicious issues. I'm going to talk about these challenges, and then I'm going to try and give you a solution to these challenges in the sense that it's not obviously a silver bullet solution, but I'm going to introduce something called the robot framework. So and I'm going to talk about why I believe it's so great that this framework exists. It's an open source framework. All of you can use it. In fact, I've built a bunch of API that you guys can fork on GitHub and use it as well. So I'll talk about the recipe part of this in a little bit and then end with some examples and demos. So if you look at any security in DevOps pipeline, it kind of looks like this, right? So you typically have all of these different security checks that you're doing in the pipeline, or you should be doing in the pipeline. You start off with threat modeling, then you have SAST and source composition scanning, you have DAST, IAST, obviously in configuration, before you deploy, you do a bunch of security checks, and then once you deploy, you have your monitoring kick in, your threat intelligence, threat detection, so on and so forth, your logging, so on and so forth, that kicks in. So this is great, and a lot of organizations have taken to this over the last 2 years very well, some of them better than others. So that's why we started doing security at different stages in the pipeline, different stages in your SDLC. So we have threat modeling, we have SAST, we have a bunch of processes. Obviously, different organizations do it differently, but this is sort of broadly how most organizations do it, at least if they're trying to do things in a pipeline. This is great, right? So everything is great. So what we're doing is at least trying to find and fix security bugs as early in the life cycle as possible. That's something we want to do because before it goes to production, we want to be able to identify security issues, react on security issues, and at least solve as many as possible. We also want security to integrate with your SDLC. So if you're doing Agile or whatever version of Agile or souped up Agile that you're doing, you want it to integrate with it. And obviously, you want security to work seamlessly with your continuous delivery pipelines. So if you have a CI pipeline, you want your security tools to run as part of that CI pipeline, give you some results at the end of the day. Some of it's good, some of it's bad. but it really depends. A lot of organizations have started at least working towards this goal, if not be in complete compliance with it. But then security folks are like this. This is what security folks say when they're presented with something like this. And how many of you are a part of an application security team within the organization? How many of you feel there are enough application security folks in your team? Okay, only one. You are a rare exception. But most places, you would see that there is a massive shortage of application security teams, right, or application security folks within the team. So recently I was speaking to this company which had 50 agile teams, and they had 2 application security folks. So which means that you tend to get very quickly overwhelmed with the amount of work. And the application security, you need to test continuously for security. That's going to be a really, really big problem, right? So let's get real. Let's look at some of the key issues that I've seen with AppSec Teams, and some of you might relate to this as well. We have some very serious issues. Let's talk about some of the serious issues that we're facing, especially when it comes to all this. Sounds great when you're talking about pipelines and automating stuff in the pipeline and making sure that your DAST, your SAST, your scanners, all of it runs very nicely within the pipeline, smoothly within the pipeline. But we have some major issues, right? Now, application security tends to get overwhelmed very quickly simply for the reasons I stated before, right? Because an application security team is usually a small group, and yes, they've got great skills, they've got a lot of experience, they do great jobs at pen testing, but they get quickly overwhelmed simply because you have to do all that you are doing as a gatekeeper process continuously across all your products' life cycles. So let's say you have 5 products, you have one application security team that is working with all 5 products to make sure that they get released on time. And they're continuously released. So you have a lot of these deployments happening continuously. You have security reviews, you have threat modeling, you have to triage bug bounty results as well. A lot of application security teams today are spending a lot of time triaging bug bounty results and saying, okay, this is real, this is not, this is just some random junk that we've received, but this is really a high value finding. All of these things are happening, and application security is at the epicenter of many of these issues. So security assessments, just to name a few. So you really have a lot of tasks that used to be, once in a gateway, yes, that was a different problem, but now you have it continuously. And a lot of application security teams aren't able to scale with that. And you're finding that, and especially with the shortage of talent, I'm sure all of you know this, that application security teams are not able to scale. They're getting quickly overwhelmed by a lot of this stuff. Automating application security is challenging as well, right? Now, has any one of you tried to automate some tools, like any tools with an API? You would see that different tools have different challenges, right? If you work with Zap, you have one set of challenges. You work with Burp, or you work with some other tool, XYZ. You have different sets of challenges. You really have, yes, these tools do a great job when you are a manual pen tester, you're working with these tools, or these tools do a great job in one sphere or in one type of check that they do, or one set of checks that they do. So you really have a lot of tools that you need to automate and you need to get working in the pipeline. And some of this is a little complex. So for instance, I don't know how many of you have dealt with some of these tools API. Some of that is not very well documented. Some of it is very well documented, but doesn't work quite as what they've described in the document. Some of it doesn't work with your platform. Some of it does not work with, with a bunch of things. So you really need to kind of scrounge around on the internet, try and figure out, okay, this works, this is somehow not working. So let me ask a question, and then comes back a lot of time later. So application security automation is not as easy as you think. Yes, in some tools, they've made it easier, but in some products, they've made it more difficult. The other problem is with custom security flaws, right? Now, yes, your Zap, your Burp, all of these tools, they find some great flaws, SQL injection, XSRF, or SSRF, or XML, external entities. They find a lot of these great security flaws. But let us say you have this custom authorization bug, which is essentially an IDOR bug or some other kind of bug, which is very, very specific to your business logic, to your platform, to your application. Then these are not really in there. right? And these are also pretty important. So you have all of these things coming from bug bounties or from internal pen tests or external pen tests, and they essentially become PDF reports or Jira tickets that may or may not get solved, depending upon what kind of engineering team you have. So custom security flaws are hard to weave into a fabric, especially because these tools do their thing, but custom security flaws are still not incorporated into that common fabric of security automation. So in short, we are essentially looking at this, right? So we have application delivery, which is going at a really rapid pace, and we have application security constantly trying to catch up. So yes, previously we were we were trying to catch up in a different way, but now we're doing different things to try and catch up. So we're still kind of short on this. So let's look at what do we need. So let's look at some of the potential solutions for what we need to solve some of these problems. Yes, obviously I'm not saying I have all solutions, but definitely some of these solutions we can tackle today. So let's talk about these three things. Engineering, run localized security, engagement with security teams and QA teams. I'll talk about make security a first-class citizen, and I'll talk about how to do that. So ideally, you want your application security teams focused on finding the really more complex, big stuff, right? In the sense that if you have security tools that can take care of all the low-hanging fruit, you really want your security teams focused on finding that big crypto flaw or that big authorization flaw, or that thing that comes up from your bug bounty, which is P1 kind of a flaw, or, something major. So you really want your pen testing teams to find more complex flaws. And instead of taking those complex flaws, writing up PDF reports and sending it over, convert them into security regression scripts, right? So that would be great, right? Just imagine if you could create a security regression script that would run the same way and then hand it over or run it as part of your CI or give it to your developer and say, run this. If this script still works, that means you've not fixed the bug. If the script has not worked, then you fix the bug. So it means that you have some kind of a regression capability, and get engineering involved in application security automation. Now this is easier than it sounds because engineering already has a large set of tasks that they need to do. So let's see how we can do this. The other thing that I feel we should also be doing is get QA or quality engineering involved. And that I think was discussed this morning in the keynote as well. That QA does a lot of automation already, right? Now, if you have a QA team, they're probably doing a lot of Selenium, they're probably doing a lot of software test automation, they're running a bunch of tools, and they already have some great expertise with automation. Unfortunately, security teams do not leverage this capability. A lot of times, security teams kind of just sideline. They don't even think about this. They don't see that these two processes kind of meet in the middle. So it would be great if we could kind of get them on board, simply because if you get them on board, you are increasing your capabilities. At the same time, you are making it a part of the engineering process, because right now security is seen as a kind of a separate process in itself. By engaging with QA and quality engineering, we can make them part of that same security test process that would be there. So it would be great. And it would be even better if we give them like a single fabric, in the sense that, oh, I don't have to run this script for this tool, I don't have to run this script. I can run everything as part of the same framework or as part of the same, as part of the same fabric. So you look at the test frameworks out there, you have a bunch of them, right? You have Selenium, you have, of course, these are extensions. Many of these are extensions of Selenium, except maybe Puppeteer, which is a Google Chrome specific test automation framework. You really have a lot of these frameworks that your QA teams are using. And some of these frameworks are a little hard to understand, especially for security folks, because you are focused on different things. Some of these frameworks are easy to understand, but you really have a lot of frameworks today. So I want to introduce a framework that essentially would try and create this single fabric. So what I'm trying to say is, you run software test automation and security testing on a single framework, on the same fabric. Weave it into the same fabric. So ideally speaking, create test suites that combine the capabilities of test automation, which is your Selenium or any other test automation tools that you have, with security testing tools. So just imagine being able to run your Selenium script with Zap, which a lot of organizations are already doing, but in a much more simplified, in a much more easy to scale way, right? To provide coverage and use pentest results as security regression. So ideally, what we want to do is create repeatable and reproducible automation that can be used by engineering teams. So essentially create canned recipes, right? So we create a canned recipe that we can use to just run again and again and again, and it will try and find as many flaws as it possibly can. So that's where I ran across robot framework. And in fact, how many of you have used robot framework here before? Nobody. It's great. You should definitely consider using this. Now, robot framework is a generic acceptance test-driven development framework, the ATDD framework, and I'll get into that in a little bit. Now, the way it works is that you have a library which is essentially compatible with the robot framework, and you have keywords. And all you need to do is invoke those keywords in a simple line of English. Something like run zap on is a keyword. Or nmap scan is a keyword. So all of these complex tasks of running zap, active scan, or spidering a site, or doing XYZ that you do in a security test is typically broken down into simplistic keywords. And you have libraries for Python and Java, and it's pretty modular. I'll get into it, and you'll see a bunch of demos as well that I'm going to be talking about. So ATDD, it's not really important, but I'm just giving you a quick example of what an ATDD is. Essentially, you write an acceptance test before you write code. That's what ATDD is. You write an acceptance test, then you write code, and you test your code against that acceptance test. So ATDD frameworks, you do have, many of you probably have heard of BDD, which is the more popular one because it has a very specific set of syntactic connotations. But ATDD is quite useful. But what we are doing today is not really going to focus too much on this. It's going to focus on what this framework can do from that perspective. So the way robot works is essentially you have your test libraries that robot runs, and then you have your test suite. So essentially what robot does is that it converts all these functions in your test library into keywords, and you can run these keywords. So for instance, I have a keyword called start zap. That means it would essentially start zap in a headless mode or GUI mode. And then I say spider, run zap spider on this particular target. Now, the reason that this is so powerful is simply because you don't need to know a line of code in order to actually do this. You don't, at least the barriers that you need to run for this is very, very low. You just need to know those keywords, or you can find these keywords, and you can just run these keywords as part of your fabric of security testing, right? So, and it automatically gives you results in both HTML and XML. It gives you all the artifacts that are required. It gives you a pass-fail status of whether this test ran, did not run, all of that stuff. I'll get to that in a little bit. So why we like it? Essentially, it's simple syntax, right? This can be given to anybody, and they can figure it out very quickly. And that's great, simply because you can give it to your quality teams, you can give it to your engineering teams and say, just run this. If you want to invoke it, just use this keyword. You're going to be invoking security tests right out the gate. So it's pretty simple, right? Easy to develop the API, it's modular. It comes with reporting out of the box. So it gives you a nice HTML report out of the box. You don't really need to do anything much for it. You don't need to write a reporting module on it. It gives you right out of the box. It also gives you, obviously it supports two very popular languages that a lot of security tools have support for. So Python and Java, a lot of the security tools have support for these two platforms. So it's great to use this. So for instance, this is an example of a robot test case, right? Now this, as you can see, is not, this is Selenium, by the way. Now, if you know Selenium, if you've written Selenium code, you'd realize that Selenium, you need to invoke a lot of functions to do all of this stuff. But here, you're essentially expressing this as natural language syntax. You're saying input text, email, with this particular class ID or this particular name of that particular parameter. Input password, this particular password, click button, submit, wait, and make sure that the location is dashboard. That's it. So it really comes down to breaking down these complex, otherwise complex test cases that were code into simple, easily understood syntax that you can use for your own testing efforts. And you have a bunch of libraries already. You have Selenium, you have Appium, you have SSH, Android and iOS automation. They already have third-party libraries for all of these different products. So let's say you're testing a web service, you can directly use the Python request module out of the box for running parameterization on the web service. Diff Appium and Selenium and so on. I'm going to quickly get into a demo of this and show you how it works, and then come back to the slides. So let's look at one of the robot scripts that I have. I'll go into, oh. Yeah, so this is one of the robot scripts that I've written for an API. So I have this really simple API that just invokes some customer functions. So what I've done is broken down each of these things, each of these operations into test cases. So what I've done first is say authenticate to the web service, then get customer by ID, get request this particular API /2. So that would give me one customer ID with these headers, right? And then I say post customer ID, then I start running Zap. So as you can see, what we're trying to use is a single fabric. We're not separating the Zap and the Selenium bit, or Zap and the functional test automation bit. So what we're doing is essentially running the functional test automation with Zap as the proxy, and we're proxying all this traffic through Zap, and once the test automation is done, we run Zap against the target and we get our results. The good thing about this is that you don't need to have 2-3 different things that you're dealing with. You're just dealing with one script. So what we're doing here is we're essentially running all these test cases. When we finish running all the automation bits, we start running Zap. We run the active scan on Zap. Once the active scan is run, we generate a report and we kill both processes. That's really as simple as this. So, and Zap, if you look at the way Zap is invoked, it just says Zap start scan. So it's really not that complicated for anyone on an engineering team to be able to figure this out. So all they have to do is just invoke 2-3 different specific keywords, and they are up and running, ready to go, right? So let me just go back to the presentation and then run the demo. So the quick start is essentially you have variables, you have test suites, you have keywords. I already mentioned the keywords and you saw some of the keywords. You can import a bunch of libraries as well. So let us say you have a generic Java library or a Python library that you want to use. You can import it into that particular script and start using it if it has a robot framework integration already. What we have done already is these two are ready to use, and they're on GitHub. You can download and use it. Zap integration is called RoboZap. I've also written an Nmap integration called RoboNmap. You can start using this right out of the box. So you can just download it, run Zap with it, and you have all of the documentation. Burp Suite, I'm almost done. I should be done very soon. Burp Suite sometimes is a little cantankerous when it comes to Jython API, but it's almost done. We've almost finished a sublister integration as well for directory brute forcing. So let us say you're a pen tester, you want to run a bunch of automation and then only focus on the big stuff. You can run all these tools as part of a pen test pipeline of sorts, and then run your custom stuff, do your manual pen testing, so that you save a lot of time instead of running all these tools one after the other. So you can just run that as part of one fabric. The future, I want to definitely work on stuff like this, which is the dependency check, Arachne, and some of the other tools. So this is where I am with these APIs. So some of the use cases, obviously, is getting engineering teams to run their own security testing. Lower the entry barrier for security testing is what I definitely want to achieve at the end of this. Let me just run a quick demo for you guys and then come back to the slides. So this is the robot script that I've written that would essentially run some functions on the web service. Obviously, we know that with web services, you can't use a spider with any traditional scanner. You can't use a spider. You can't do any of that. So you kind of have to run through the parameters specifically one after the other. So let me just run this. So what this is going to do is going to run those. It's going to authenticate to the web service. It's going to invoke a few functions, then kick off Zap to run an active scan. And you'll see Zap, I've configured it to work on the GUI mode, but you can run this headlessly as well. And then once Zap runs, it's going to write the results to a JSON file. That's simple, right? So let's just run this, and you'll see how it works. So it starts Zap. And Zap is running on another desktop. That sucks. Just give me a minute. Yeah, so yeah, this is Zap. And I'm going to just bring this in as well. Probably just going to reduce it. So Zap is started up, and now all the traffic, as you can see, is being proxied through Zap. So I'm logging in, and I'm calling 3 or 4 different functions. And once I'm done with this, I create a context with Zap, and Zap is going to start an active scan very soon. So it's going to start an active scan, and you can see that each of these steps are represented as modular entities here. So you can see that get customer ID. I've done all of these different functions, create a Zap context, run an active scan. Once the active scan is done, it's going to write the report and shut it down. That's it. So with this, your actual automation is pretty much done. Right? So you really have, you've lowered the entry barrier for your QA teams to get into security testing simply because you've been able to give them a repeatable process. And in fact, Robot Framework, if you ask your QA teams, that you'll be surprised to know that a lot of people are already using this because it's heavily used in the test automation world, but unfortunately in the security world, it's very little known. So it's pretty easy to get started with something like this. And obviously by providing them a simple API, all they have to do, yes? Right. Or do you give them a report, like what's the... Right now, this gives them a report. So this gives them a JSON report. So let me just try and pull that up. So this would be the... So it generates a report at the end of the script. So as you can see here, this is the report that it generates. It generates a JSON report for the test it ran at this time. And it just gives you all the details of that right now. But you can use it however you want. You can send it off as an email, or you want this to be triaged by the security team to remove false positives or whatever it is. All of these flows can be worked out. But typically right now, the APIs that I've implemented either write it to our product, which is the correlation tool, or just generate a JSON file, which you can use. You can slice and dice and use it how you will. Right? So, so really, if you look at the security use cases, there are quite a few use cases that I would go with. One, definitely to empower engineering teams to run their own security tests, simply because engineering teams, you don't want them coming to you for everything. Ideally, that's what you want them to do, right? Have their own security practice, run a set of security things by themselves, and then obviously for more specific, more value-added type of services, approach your application security team or your security group. Functional test automation can be, so in fact, this was an interesting story. We were able to convert a Selenium script for a pretty massive product to robot within 2.5 hours. Which means that the ability to scale with this is pretty easy. So let's take a massive Selenium script, you just convert all of that over to robot, because robot has the same Selenium API. So it just has keywords for those Selenium scripts, and you can just convert that into robot framework pretty easily. For pen testers, it's great because you can kind of automate all that low-hanging stuff, right? Okay, I'm going to run this, I'm going to run Nmap, I'm going to run sublister, I'm going to run Zap, I'm going to run Bub, and only after that I'm going to look at the product. So if the pen tester gets a test automation script from the QA team, all the pen tester has to do is run all of this stuff and only start to look at the more specific, more critical flaws in that particular environment. So the idea is to break down all of this stuff that used to be a friction driving process and make it something like this, which is very easy, very simple, very intuitive for people to understand. Right? So let's look at some of the use cases and patterns, and I'll run you through another demo in a little bit as well. So automated pen test activities, creating a pen test pipeline. So one of the visions that I had for this when I started off with this was for our own internal team that was running pen tests, was that, you know what, guys, instead of running all of these tools manually, why don't you have test automation script, run it through robot, and therefore you actually run it through all the different tools you would otherwise use in a pen test, and then write them back for you to see what it found, what kind of security issues it found, what kind of flaws it found, and essentially creating a pipeline. So you can run Nmap find all the port scan results and the vulnerability scan results from MNAP. In fact, we even wrote a Nessus integration at the time when Nessus used to have an API. And we used to actually automate that whole process of running Nessus. Then we used to run a directory brute force tool, run Zap, run burp, and then come out with the results. So we had all of these results in a database that we could triage and then figure out what were the security issues that we actually found. So creating some sort of a pen test pipeline, kind of enhancing the capabilities of security teams. The other thing that we also have been using this for is parameterized application security testing, right? Now, one of the things that I'm sure some of you will know is that with security tools like Zap or Burp or any of these other tools, one of the big challenges you have is doing authenticated scanning, especially against web services or single page apps, all of these different products which are not easily spiderable. You don't have spiders that can do a very good job of this. So ideally what we did was use Selenium scripts or other test automation scripts, use that as input for these scanners. These scanners capture all that proxy, all of that traffic, and then you run your security tests after that. So that's another use case. And obviously, one of the other things that we also started using this for was, let's say your pen tester finds an amazing authorization flaw that is very specific to your app, to your environment, or to your particular business logic. Instead of showing that as a bunch of screenshots, convert that into a robot script and run it and say, this passed, this failed. Great, right? You can get much more immediate feedback from that particular process in a much more easy way. So now this is a pen test pipeline. So for instance, this is what I'm talking about. So run Nmap first, print the results, run Zap, get the results, and you're done. So you have some of these patterns that you can merge. So let me just show you a quick demo of this as well. And I don't have too much time, so I'm going to kind of run through this demo. Oops. So this is actually, if you look at the script, and I'll show you the script as well, is a, this is a Selenium script. What I did now was just a web service. It ran some web service requests with an HTTP client, but this is actually a Selenium script. So what this does is that it runs an Nmap port scan against that particular vulnerable app. It's an intentionally vulnerable app on my system. It runs the port scan, then it starts Zap, then it creates a browser. In this case, I'm using Phantom.js. You can use Firefox, you can use Chrome in headless, in the headless mode. So it starts Phantom.js, which is by default a headless browser. And then it logs into the application, visits some random pages, starts up Zap, runs Zap, and terminates the scan after writing a result. So let's just run this script and show you how that whole pipeline process works. So this, I just need to invoke the script, and it starts with an Nmap port scan. Obviously, I'm not running a very, more powerful Nmap port scan. I'm just running the default. Then it starts Zap. Zap is started up again, as you can see, and then it runs all of the other stuff. So it's going to log in. It's going to open up the URL pretty soon. It's going to log into the app very soon. And it's going to start the active scan very soon. So yeah, it opened up the login URL. It's going to log in with those particular credentials. So even if you're testing single page apps or web services or something a little more complex that your spider is not going to be able to ever catch, you want to run it with specific inputs that give you specific outputs that you can use for a more efficient, more effective scanning process. You can use something like this because it becomes very easy to scale. And you can give this as a recipe, right? You can just put this in a CI pipeline in Jenkins. In fact, Robot has a Jenkins plugin. So you can just put this in your Jenkins box and just say, invoke the Robot plugin and say, run this particular script every night. That's it. So it becomes a lot more easy to do. So as you can see, it's still walking through the app. I should have eliminated the JS bit. I don't know why I just spidered everything. Anyway, so it's running all of this stuff, and it should now start the active scan as well. So while this is running, I'm just going to finish up the rest of it because it's going to take a little bit of time. So yeah, so you are on that. So if one of these activities fail, it would essentially throw a fail, and then it would give you a report with the fail notification. Now the reports are pretty good. They look like so. I'm going to show you how the default report looks, and it's pretty intuitive. So this is what a default report looks like, right? So you have all of these different tasks that I've run, and you can see the zap scan results if you want. I think it gives you each of the test keywords that you've run. So each of the keywords has, so if you're logging stuff within the keyword, you can get a detail of all of the different keywords that you've run against. So you see that it gives you a scan status, and then it's generated a report. So it's generated a report, and then it's killed zap, killed the browser, etc. So it gives you all of these. It's pretty useful because you get a running status of what's happening and what's happened with that particular script. You know whether something has failed. Let's say a UI component has changed. You limit it. Obviously, it would fail. It will tell you that this particular script failed. The good thing with this is that since it's modular, failing of one of these test cases is not going to result in your entire test case or your entire script failing. So it's just going to say that, okay, that failed, but I'm still going to continue as much as possible and run it. Right? Yeah, so that's the idea. What I eventually want to do is create a pipeline of tools that can be used with Robot Framework. Right now, Zap is something that I already have. Burp is pretty much done. I think I just need to put some final touches on that. Arachne and all of that stuff is still not done. Yeah, so parameterized application security testing, so you can run even your custom scripts. So instead of creating them as PDFs, create them as regression scripts, run the entire thing as part of one single test case or one single test suite where you say that, okay, run all this automation first, then check for these securities, these particular security flaws that have been found by my pen testers to say, okay, this authorization flaw is still open, this crypto flaw is still out there in the wild, whatever. So you can still run the entire set of events. So some questions that I kind of preempted. One, why not BDD? BDD was definitely an option that I was going with, but I did not like BDD so much, to be honest. I'm sorry if I'm going to offend a lot of people in the room. BDD restricts you to a syntax, right? Given this, when this happens, then do this. Now, with this, you're not really restricted to any syntax. You're just saying, call this, call that. It's more data-driven, whereas BDD is more behavioral. I did not need something as complex as that. I just needed something simpler, so I went with this. All tools easy to integrate. It depends if the tool has good API. For instance, Zap has amazing API, so it's easier to integrate. Yes, but typically if they have some kind of integration point, some kind of API, some kind of flat files that you can work with, you can even do something with that. Parallel execution is possible. So let us say you want to speed up execution parallelly. So let's say you want to run Nmap separately, you want to run this separately, you want to run that separately, you can actually do that. There is a integration to robot called Paybot, P-A-B-O-T. Paybot allows you to run in, as a multi-process kind of thing with parallel execution. The next thing I want to do is run all of this in Docker. That's something that I'm really working on, because with Docker, you really are achieving all of this without all the unnecessary dependencies having to be installed on every single machine. So that's something I'm going with. The future, obviously, my team and I will be working a lot on Robot Framework. We've seen a great deal of value with a lot of our clients as well. And we've been working on this API. I highly encourage you to go and download some of the stuff that we've put out. Definitely happy to have more people contribute, more people give us ideas that we can go, obviously, be a part of this whole journey with us. With that, thank you very much. I really, you've been a great audience. Thank you. I hope you guys have found this useful. Yes. Yes. I forgot to put it on there, but yeah, you can just go to my Twitter and you'll find a bunch of GitHub links tweeted there. I can give it to you otherwise. It's not on my presentation, sorry. Any other questions? Thank you so much.